Storm 11, runway 23 at Delta, wind 220 at 7, cleared for takeoff.
Marine Corps Air Station, New River, North Carolina.
Left base, runway 23, follow V.
Today, at this vast facility, Squadron Commander Lieutenant Colonel Hawkins and his team are preparing for an artillery training exercise designed to simulate a very real conflict situation.
Historically, Marines have been the first to fight. That's what we live and fight for. We're the 911 force for America, and we're ready every day of the year.
Crossbow 4-1, check wheels down, runway 23, wind 25010, clear to land.
So in order to do that, we prepare and train across the globe for every future conflict.
But moving man and machine into some of the remotest and most inhospitable areas on the planet can present an enormous challenge.
We must be ready to move heavy equipment over long ranges from the sea to the objective to ensure Marines have what they need when they need it.
To ensure that no matter where conflict arises, the Marine Corps are fully equipped and ready to respond, they turn to the sky and a helicopter with some jaw-dropping capabilities. This is the CH-53 Echo Super Stallion. Measuring 30 meters long and standing almost 9 meters tall, this vast aircraft is designed to transport troops and equipment anywhere on Earth. Powered by 3 massive turboshaft jet engines. Combined, they produce more horsepower than 13 Bugatti Veyron supercars. Spinning 7 main rotor blades with a diameter of 24 meters, the Super Stallion can reach a top speed of just under 200 miles an hour. Designed to be able to move huge cargo loads into position, it can carry up to 55 troops or 7 pallet loads of supplies internally, or over 16,000 kilograms of weight externally. Across the base, inside Squadron HMH 464's locker room,
Buddy, how we doing?
Super Stallion pilot Captain Clayton Cottrell is preparing for today's mission.
Our mission today, we're doing an artillery raid in support of 10th Marines. My role is Dash 3 aircraft commander. We're utilizing 3 53s to conduct the raid. And so I'll be the aircraft commander in the last aircraft. So with me in the aircraft, I'll have 2 additional co-pilots, 1 crew chief, and then 2 additional aerial observers and gunners. And then as we do these external lifts, they're vital to position the external hooks in the right place so that underneath the aircraft, the helicopter support team personnel can hook up the loads.
Once airborne, Captain Cottrell, as well as 2 other Super Stallion crews, will be lifting and moving into position 4,000-kilogram howitzer artillery guns. Ready to be fired by the Marines on the ground.
Heavy lift externals are kind of the bread and butter for the 53, and I love doing that.
Out on the apron, the 3 aircraft are fueled and almost ready to depart.
This is kind of the last check of doing a walk around to make sure that there's no latches undone, anything out of the ordinary. You can see we've got our crew in the back, already working to set up our hooks that we'll use for both the single point and dual point externals that we'll be utilizing to conduct the heavy lift externals for today's artillery raid.
With the final pre-flight checks complete, the team are ready to take to the skies in this formidable machine.
Base 2324 outbound.
But how have engineers built an aircraft capable of moving the equivalent weight of 10 family cars through the air?
It is extremely difficult to design and build a helicopter capable of lifting 36,000 pounds.
And ensured that when its 3 jet engines begin spinning 7 massive rotor blades, this vast machine remains controllable.
This aircraft just getting off the ground still amazes me.
Finally, how have engineers protected the aircraft and crew so that this huge helicopter can operate in a war zone?
So anytime we're out there flying, this large of helicopter is going to present a big target for the enemy.
When the US Marine Corps need to do some heavy lifting out on the battlefield, they turn to this. The CH-53 Echo Super Stallion. This vast heavy lift helicopter can operate in all weathers on all terrains. Capable of taking off from a ship at sea with a load weighing up to 16 tons attached, it can carry it up to 160 kilometers before delivering it to troops on the front line. Its potential is unmatched by any other helicopter in the US military arsenal. But engineering a machine capable of lifting and flying the Marines' vast arsenal of heavy-duty weapons and vehicles into position is a major challenge for people like pilot Captain Clayton Cottrell.
So when the Marine Corps enters into a conflict, it takes a lot more than just the Marines to make that operation happen. The Marine Corps had a multitude of assets, whether it's vehicles or heavy weapon systems that have to be transported and moved throughout the battle space.
But moving something like a 13-ton lightly armored vehicle hundreds of kilometers by air requires the Super Stallion to have some distinct capabilities not found on other helicopters.
In order to lift heavy cargo or supplies underneath the aircraft, you have to have a stable platform, you have to have a lot of power, and then you need an aircraft frame that's capable of withstanding those forces throughout the entire operation.
So could a blueprint for the perfect heavy lift helicopter design lie in the innovations of the past? Lifting a large amount of weight with a helicopter is an enormous engineering challenge. Firstly, you need to work out where to store the load. Having a big internal cargo hold is great for lots of smaller items, but for the bigger ones, you need another solution. Once you've solved that problem, it's time to tackle the horsepower issue. You need enough to get off the ground, and then some extra to ensure that you can stay in control even when it gets windy. Finally, you need a way to make sure that when it comes time to drop off whatever you're carrying, that it lands in the right place. In the state of Missouri in the USA, Doug Sopersky and his team are tackling a vast and problematic engineering project.
We're out here east of St. Louis installing lattice-type power line structures.
Each piece of these giant towers can weigh over 9,000 kilograms, making getting them into position in remote locations like this one a huge challenge.
Generally, when they call us, you can't get conventional cranes out to the sites where they need the structure standing. The turf is too muddy. There's a reason that they can't get conventional ground cranes in there.
For a solution, Doug and his team must turn to the sky, and an historic machine unlike any other on planet Earth. This is the S-64 air crane. Originally designed in the 1960s, this game-changing flying machine was built with a simple goal: to transport more weight by helicopter than had ever been done before. Created by aviation pioneer Igor Sikorsky, it was first used by the US Army during the Vietnam War. Offering unparalleled transport and aircraft recovery capabilities, the S-64 was incomparable to any other helicopter of the time.
It's very unique to itself, yeah, and everybody knows when they see one of these that it's the only one shaped like this.
Based on a design that's more than 60 years old, today the air crane remains one of the world's most powerful heavy-lift helicopters.
Currently, we're in the external load configuration for setting anything from power line structures to HVAC units.
What makes this feat of engineering possible are two massive turboshaft jet engines, producing a combined total of around 9,000 horsepower.
They're big engines. They're Pratt & Whitney engines, but they're 4,700 horsepower apiece, capable of lifting us up to 25,000 pounds external load.
This huge amount of power means the S-64 can lift almost the equivalent weight of 2 African elephants. But to put this power to good use, Doug and the crew also needed a way to control it with millimeter precision.
This is our aft-facing pilot position, and it is what makes the Sky Crane so special. Facing backwards, flying the aircraft, allowing us with this great visibility so we can get these giant lattice towers set precisely. We have full control back here. It's a smaller window. They say we only have 10%, but you do have full control back here. If this wasn't invented, what I would have to do is you stick your head out that bubble on the left and you fly your external loads on a long line. It'd be a lot more difficult, more dangerous because of the rotation and trying to get guys put their hands on the units now and push it into place.
This engineering combined has created a helicopter with a set of mind-bending capabilities. And with the aircraft refueled, it's time for Doug and his crew to get back to work.
Generally speaking, the right seat pilot is flying the aircraft. We'll position over near the load where the aft seat guy can start picking up what we're picking up into his visibility. He gives the rigging to the guys on the ground. They'll hook us up. Aft seat pilot picks the load up off the ground out of the fly yard. As we get close where it needs to be set, and the guy in the aft seat can see where he needs to set the unit. It's just a verbal exchange of flight controls at that point, and the aft seat guy takes over flying.
Let's make sure that forward right here, yeah, there you go. 8, 7, 6, 5, 4, 3 foot, 2, 1, inches. There you go, you gotta capture all the way around. You are clear to release forward. Stay it on there. Forward loops are clear.
More than half a century after its first flight, the S-64 air crane is still in use across the globe.
Due to its unique capabilities, aft-facing pilot, its stance, designed for external load, obviously it's still being used today for different applications. Doing what I do in the heavy lift industry, I'd say this is the best tool that there is.
Today, the team have taken the engineering at the core of the S-64 air crane and evolved it for modern warfare. And high in the skies above North Carolina, Captain Cottrell and his crew are en route to tackle the first task of their training mission.
Right now we're flying inbound to LZ Bluebird, so once we get there, we're going to go in, we'll pick up the guns. So we have 3 aircraft and 4 cannons to pick up. We're going to pick them up simultaneously and then depart 2 aircraft at a time back to LZ Bluebird and drop them off simultaneously in LZ.
By using the Super Stallion's external load hook system,
Everyone be advised that 2-3's over the first load right now.
the crew are able to carry the 4.5-ton howitzer artillery gun with ease.
2-3 make sure he's on the go. You can definitely feel it under the aircraft. It kind of depends on the weight. Different external loads have different flight characteristics. So based on what the shape is, they fly through the air differently. That's going to affect how the aircraft flies.
This vast machine has taken the heavy lift helicopter concept to another level.
The aircraft itself has a single main rotor with 7 main rotor blades, and then you can see the tail rotor with the 4 blades on the tail. Another unique capability of this aircraft is to be able to fold the blades as well as the tail for shipboard operations in that smaller footprint. Additionally, we've got 3 General Electric engines that all provide power and input into that main gearbox to supply that, ultimately that lift to the main rotor head for the 53.
6 tons heavier than the pioneering S-64 air crane, yet capable of lifting over 7 tons more weight. The Super Stallion's incredible capabilities come from its 3 massive engines, each one producing over 4,000 horsepower.
All right, so now that we're coming into the cabin of the aircraft, you can see, kind of get a scale for how big the cabin of the aircraft is. On either sides, we've got seats on either side. This is where Marines would sit with their gear.
Capable of accommodating up to 55 Marines and their gear internally. For external lifts, 2 innovative hook systems allow the Super Stallion to transport vehicles or other aircraft with ease.
Conducting external operations, we'll either use our dual point system, which are on either side of me here, or we'll use the single point system. And what we'll do is we'll open this door, and then that hook system, this A-frame drops down, and we extend that hook directly underneath the center of the aircraft in order to conduct those operations. All right, so up here is where we have our pilots. So you can see the array of our flight instruments up on the front, and then kind of what our vantage point looks like out over the dash and to the sides of the aircraft. Piloting the 53 is really no different than any other helicopter. You've got the same basic controls with your collective, giving you your up and down, your cyclic, your fore and aft, and your lateral motion for the aircraft, and then your pedals up front, which control the yaw. Up top, we've got our speed control levers, which control those engines, and then up front, we've got all of our instruments that provide us that information about those engines.
But when it comes time for this vast helicopter to pick up a load, it's not just down to the pilots to guide it into position.
Me as the pilot up front, flying the aircraft, I'm primarily looking outside over my shoulder to pick up reference with the ground. And then primarily I'm listening to our crew chiefs in the back. So we saw the hole in the cabin floor, which is where the crew chiefs will position themselves in order to maneuver the helicopter over the external load. So really I'm getting through our intercommunication system all of my cues for where exactly to put those hooks that are about 20 feet behind me from the crew chiefs in the back as I'm looking outside the aircraft to maintain a stable hover.
But carrying such enormous loads with a helicopter that already weighs more than 6 shipping containers creates a problem.
When we're conducting external operations with an external load underneath the aircraft, it's going to create a higher fuel burn and therefore less flight time.
Unladen, the Super Stallion has a range of 800 kilometers. At maximum lift capacity, this is reduced to around 160. To overcome this problem, engineers have given the Super Stallion an ability rarely found on helicopters.
One of the key things that facilitates us being able to conduct helicopter air-to-air refueling is the system that extends this probe to approximately double the length that you see right now. What that does is provides us the clearance to be able to make contact with the refueling asset and be able to take on that fuel safely.
After rendezvousing with a tanker mid-air,
Wind is pretty good. Just
pilot must guide the Super Stallion's refueling probe into a drogue basket, measuring just 60 centimeters in diameter.
First time I conducted air-to-air refueling as a 53 pilot, it amazed me how close we have to get to the tanker.
C3 is just going to push it. Yeah, it's looking good.
Flying that close to a tanker takes a lot of crew coordination and precision flying that close to another aircraft.
Getting the Marine Corps' biggest pieces of essential warfighting equipment to the front line requires a machine with some incredible capabilities. This is the CH-53 Echo Super Stallion. The largest helicopter in the US military inventory. It's 3 times longer than a Cessna light aircraft and weighs more than 2 F-16 fighter jets. Its vast external fuel tanks allow it to fly the equivalent distance of London to Berlin without refueling, at just under 200 miles per hour. But such vast power presents a problem. How do engineers deal with the forces created by a more than 20-meter diameter rotor spinning at high speeds? Aircraft maintainer Master Sergeant Rowe is part of the team responsible for looking after this complex piece of engineering.
The CH-53 Echo has 3 turboshaft engines, and they produce just under 5,000 shaft horsepower each. During operations, the rotor head turns at approximately 180 RPM per minute, which is a lot of power.
It's this rapid turning of the main rotor that produces lift, allowing the Super Stallion to get off the ground. But the immense forces created by having 7 blades cutting through the air at such high speed also creates a problem.
As the rotors turn, you have multiple forces working against it, like torque, lift, and drag. Without being able to control the adjustments of blades in flight, it would cause a disparity.
Left unmanaged, these forces could create more lift on one side of the helicopter than the other, potentially causing it to roll and ultimately crash. To ensure that this doesn't happen, engineers must look to the aeronautical pioneers of the past for a solution. On an airfield just outside London.
And we're in the air! Okay. What a ridiculous contraption.
Physicist Andrew Steele is taking to the skies in a type of flying machine that revolutionized aviation.
At first glance, you might think that this beautiful aircraft is a helicopter because of that enormous spinning rotor up there. But actually it's something slightly different called an autogyro or gyrocopter, and it works on a rather different principle. The power in this autogyro is provided by a propeller on the back of the aircraft, and what that means is that it moves us forwards. As we move forward, the air flows over that main rotor, which spins it around and around, and of course this aircraft doesn't have any wings, so this is very much like a small pair of wings spinning around very, very rapidly over our heads, keeping us in the air. This machine might seem like the perfect fusion between aircraft and helicopter. But unfortunately, when engineers were trying to construct these things back in the early 1900s, they ran into a problem. That problem was that as you move forward, you can get a different amount of lift on each side of the rotor blades, and that can cause the aircraft to roll and, well, basically crash. So the engineers needed to find a way to control those rotor blades more precisely.
In 1923, Spanish pilot and inventor Juan de la Cierva came up with an ingenious solution to this complex problem. And at the de Havilland Aircraft Museum, Andrew is getting up close to the engineering brilliance behind one of his early designs.
Look at this piece of aviation history. This is the Cierva C-24. It was first flown in 1931, and this is the only version of this model ever built. It's so precious, I'm not even allowed to touch it.
De la Sierva developed the C-24 in relative secrecy at the Stag Lane Aerodrome near London. But to make it a reality, he faced a problem that had plagued engineers for years.
The problem Sierva faced is called dissymmetry of lift. What that means is a different amount of lift on different sides of the aircraft. So let's imagine the aircraft is moving forward and of course the rotor blades are spinning round. This blade here that's advancing into the oncoming air is going to experience a greater amount of lift than this blade here that's receding away from it. What that means is you've got a greater lift on this side than on this side of the aircraft, and unless you do something about it, that means the aircraft's going to roll and potentially you could crash.
To overcome this problem, Sierva designed his rotor control system around 3 hinges.
This system is called a fully articulated rotor, and the way that it works is it gives the blades some freedom to move in various different directions. There are 3 hinges in this system. First, we've got the flapping hinge, which gives the blade freedom of movement to flap up and down a little bit. Then we've got the drag hinge, which gives it a little bit of freedom in the horizontal direction. And finally, we've got the feather hinge, which allows the whole thing to just rotate about its axis. And all of this allows the blade just to compensate for that change in lift on either side of the aircraft. It feels quite counterintuitive that just letting the blades flap around a bit could possibly solve this problem. But actually it does work to balance the forces on either side of the gyrocopter.
Back in the skies above southern England.
This is amazing! You can do such tight turns in this thing.
Andrew is getting the opportunity to put Sierva's game-changing machine to the test.
No pressure, but it's all you, OK? Back pressure on the stick as you turn, back pressure, that's
there
it.
we go.
Stop those dropping.
Slows us down.
Good. That's good.
And then, like you say, it flies itself.
It does, just take your hands off.
Hands
I got
off.
my hands off.
Hands up, hands up. What an amazing machine. Sierva's contribution to aviation was enormous. The Autogyro was groundbreaking, and the fully articulated controls on rotor blades are what's allowed helicopters to exist as we know them today.
In the skies above North Carolina, Captain Cottrell and his crew are halfway through their training mission and en route to drop the artillery pieces to the Marines on the ground at the landing zone.
So once we put the guns in the zone, they're going to get fire cap, so they're going to be able to start their fire mission. They're going to start shooting live fire out to the range complex. 5, 4, 3, 2, switch ground.
Making this feat of aeronautical engineering possible is the Super Stallion's own fully articulated rotor system.
It is a big aircraft to fly. We're approximately 100 feet long, so as big as we are, and when you first start flying it, it's surprising to see what really small inputs have a big impact on what the helicopter does. So it's very agile, maneuverable, and powerful aircraft.
And back at the hangar, Master Sergeant Rowe is getting up close to this vital component.
The rotor head itself is massive. It's large enough for multiple people to sit on. Everything that happens with the aircraft goes through the rotor head. And up here we have the articulated rotor head. The articulated rotor head system is an imperative part of the aircraft and makes it possible to do what the aircraft is capable of.
The Super Stallion's fully articulated rotor system works in the same way as the Autogyro. The drag hinge, flapping hinge, and feathering hinge all work together to ensure that the forces acting on the blades in flight remain balanced. Also located on the giant rotor head is the engineering system that translates the pilot's controls on the stick into movement.
So this large component right here is what we call the swash plate. And this rotating swash plate here is what it controls all 7 blades at the same time for each position of movement. As the pilots are making inputs down in the cockpit, the power adjustment is transferred through the rotor head via the flight controls. Right here at this rod is where the input to the blade goes, and which changes the pitch of the blade and in turn controls the aircraft.
As the swash plate moves, the input is transferred to the blades, changing their angle, allowing the helicopter to ascend, descend, move forwards, backwards, left and right.
The response is almost immediate from the pilot's input to the rotation of the aircraft at the blades. For the size of the aircraft, it's incredibly responsive.
The team may have found a way to control this vast helicopter, but they now face a problem that has the potential to render the Super Stallion almost completely unusable on a large part of the planet. Brownout.
The best way I could describe a brownout condition is when you're going and landing in a sandy environment. As the aircraft gets down lower and closer to the ground, all the loose dirt and dust comes up and engulfs the aircraft.
Caused by downwash from the helicopter's 7 rotor blades, brownout is one of the most challenging and dangerous situations pilots can find themselves in.
It's going to reduce the visibility of the pilots and crew, and it can also have an effect on the operation of the engine by sucking in dirt and reducing the amount of airflow that goes into the engine to create power. The less power you have, the less lift you're going to be able to provide in order to keep the aircraft and the crew in the air and safe.
The problem engineers face is that a traditional filter would rapidly become blocked, rendering it useless. To overcome this, the team have devised an ingenious solution.
This is the EAP system on the aircraft. What this does is it acts like a giant filter for all the air going in and out of the engine. The stratotubes here are cyclone filters that as the air and debris are sucked in, they spin around, it goes through into the chamber of the EAPs. All the dirt gets sucked out here via the blower, which allows the clean air to go into the front of the engine.
As dirty air is drawn into the engine, it's spun into a vortex, causing it to speed up, increasing the amount of centrifugal force acting upon it. This causes larger pieces of debris to be pushed out and allows clean air to pass into the engine.
The EAPS is definitely an important part of the aircraft. It helps keep our engines running efficiently and helps reduce engine degradation from debris going through.
This is the C-53 Echo Super Stallion. Capable of transporting up to 55 troops, or the equivalent weight of over 40 grand pianos. It's powered by 3 jet engines that give this vast aircraft over 70 times more horsepower than the world's first mass-produced helicopter, allowing it to operate anywhere on the face of the planet. Today, in the skies above North Carolina, Captain Cottrell and his crew are nearing the end of their training mission.
We just finished the mission. We dropped off the all 4 guns, and we'll head back to New River now to refuel. Over here, if you can see them, so we have our primary flight instruments. So this is what we fly off of. It tells us things like our heading, our airspeed, our altitude above the ground. In the center, you've got fuel gauges here in the middle. There's basically a stack for each engine, so they're telling us what each one of our 3 engines are doing. Depends on our weight and the ambience and everything like that, but we can usually fly from 3.5 to 4 hours, depending on what we're carrying.
Capable of flying 800 kilometers before needing to refuel, the Super Stallion has a huge amount of range for its size. But flying thousands of liters of highly flammable liquid hundreds of meters in the sky presents a dangerous problem.
As you can see, it's a pretty large helicopter, so anytime we're out there flying, this large of helicopter is going to present a big target for the enemy. Really, any damage to the aircraft is going to impact the air crew's ability to operate the helicopter, and it's going to impact their decisions in the continuation of the operation.
But there's one area of the aircraft in particular that, if damaged, can present a multitude of problems for the crew on board. Its 2 vast external fuel tanks.
If there's any damage taken to the aircraft and there's leaking fuel, obviously that's going to impact the amount of flight time available. There's a potential, with that being a flammable liquid, of that igniting and causing a hazard to the air crew. It's going to be a very serious situation for the air crew to have to deal with.
To overcome this potentially life or death problem, engineers must look to the innovations of the past for inspiration. Flying low over enemy territory has been a dangerous job since the early days of aerial combat. And over the decades, there's been many attempts at finding ways to make it safer. In World War I, aviation engineers experimented with armour plating. But the extra weight made the planes less manoeuvrable and they consumed a lot more fuel. Then there's camouflage. During the Second World War, British engineers painted a handful of reconnaissance aircraft pink. An unusual choice, but it helped them to blend in against low sun. Another approach is just to go really fast. The SR-71 Blackbird could travel at speeds of over 2,000 miles per hour, quick enough to simply outrun any incoming missiles. But when you're flying a helicopter that's longer than a basketball court, you need to come up with a different solution. At the Palm Springs Air Museum in California, pilot Tom Nightingale is discovering a life-saving innovation hidden deep within one of the most iconic aircraft of the Second World War.
Okay, so this is the P-51 Model D Mustang. Fantastic fighter, my favorite airplane of all time. Airplane is so nice to fly. It has incredibly balanced controls, very, very responsive. Just a super, super airplane to fly.
Designed to escort Allied bombers hundreds of miles into enemy territory, the P-51 was one of the most capable aircraft of the era. But covering such vast distances presented a dangerous problem.
So if we're standing back here in the back, we can see relative to the size of the airplane how big the fuel tanks are. The fuel tanks are going to be from about here to about here, all the way probably here to the front. And there was also an 85-gallon fuel tank about right here behind the pilot.
Carrying this much highly flammable fuel was a necessity, but it presented two distinct dangers to the pilot at the controls.
One would be if the fuel tank was penetrated by a projectile or a bullet, the fuel tank would leak fuel. B, it could catch on fire. So in that case, of course, if you had a fire and you burned a wing off, you'd have to bail out. Or if it just leaked fuel and didn't catch fire, you may not have enough fuel to get back to home base. So you may end up, landing in the English Channel, or landing in France or somewhere.
To ensure that neither of these situations happened, engineers employed an ingenious solution. In 1918, inventor George Murdoch patented the self-sealing fuel tank, a life-saving idea that would revolutionize aircraft design. Constructed from layers of vulcanized and natural rubber, when penetrated, the fuel is able to mix with the untreated parts of the tank, causing the natural rubber to turn to a gel, plugging the hole. Fitted to almost all Allied bomber and fighter aircraft during the Second World War, Murdoch's innovations saved countless lives.
We're going to go through and right, 151 Bravo, thanks.
And today, this game-changing piece of aviation engineering can be found not only on military aircraft, but civilian planes as well, vastly reducing the chance of a fire if a crash occurs.
I think the advent of the self-sealing fuel tank definitely had a huge impact on the effectivity of these airplanes and the safety of the pilots, and in my opinion, definitely helped this airplane turn the tide of the war.
Back at Marine Corps Air Station New River, Murdoch's invention has been reimagined for modern warfare. And it's up to Master Sergeant Rowe and his team to maintain these essential pieces of engineering.
The fuel itself is stored here in the sponson. The quantity of fuel contained in each sponson is about 490 gallons. Inside the sponson, there's a rubber bladder, which is a self-sealing fuel tank.
Over 100 years since Murdoch first patented his idea, the concept behind the self-sealing tank remains the same.
In the event of a puncture of one of the fuel bladders, the self-sealing compound will take over and seal the hole to prevent leakage.
These highly classified pieces of critical engineering are located inside the aircraft's two external sponsons. Constructed from a specially coated nylon polymer, they're flexible, allowing them to withstand vibrations and movement in flight. On the inside, a natural rubber layer is still used. If the tank is punctured, it makes contact with the fuel, forming a gel, plugging the hole within 2 minutes. Proven in the field, the self-sealing fuel tank is a life-saving invention.
I have seen a fuel tank puncture, and the self-sealing compound does what it's designed to do. This aircraft really is an incredible piece of engineering.
Back on board the aircraft,
Condor 23, single 53, inbound to LZ.
After completing their training mission,
Dash 3's on deck.
Captain Cottrell and the crew are touching down back at base.
So the mission went well. So, you know, doing heavy lift, you gotta watch the gearboxes, the temperatures and the oil. Our aircraft today performed very well. For the Marine Corps, that's what marine aviation is all about, is supporting the Marine on the ground.
The Super Stallion has redefined what a helicopter is capable of.
Throughout my career, I've been around a lot of different types of helicopters. Every day I see the Super Stallion, I'm amazed to be part of the team that flies that incredible aircraft.
By looking to great pioneers of the past for inspiration, adapting their ideas, refining their designs, and overcoming monumental challenges.
I'm extremely proud to be involved with this aircraft. I had a lot of opportunities and a lot of different choices when I came in. This is where I want to be.
Out of all the aircraft and all the helicopters that are in the Marine Corps, I'm exceptionally proud and humbled to be a part of the 53 Echo and the Super Stallion community.
Engineers have constructed something radical and succeeded in making the impossible
2324 outbound.
possible.